Hi everyone, this is Trash Pirate, and I'm going to talk about Chainlink because this morning we had hosted a space and talked about Chainlink in detail, but we had some audio problems, so I would like to record this again and just give a really broad overview about Chainlink, a project that I really like because it's one of the projects that addresses the key problems we have in blockchain development and in Web3. And most people, they're just focused on the price of a coin. They know about the project because it's in the top 100 in terms of market cap, but they actually don't really know what's behind the project and what's the innovation and technology that's being developed by these projects. And Chainlink in particular has contributed so much to the Web3 space. So that's why I would like to give an overview for founders, for example, to get a better idea what's possible in terms of development, for users to just get a better understanding what's actually happening in the space. So Chainlink has actually 6 different services at the moment. I'm sure that's going to expand in the future, and I'm going to go over each of those. Some of those you probably have heard of, some less. But let's first dive into just how generally Chainlink works. So I'm here at on the docs, like docs.chain.link. There you have everything that you need to know about Chainlink, especially if you're a developer. And so we can look at just how Chainlink generally works. So they have here a nice overview of the architecture here. And that's just a very broad, crude overview, but in general, Chainlink works like that. So as you may have heard, Chainlink is actually an Oracle network. And Chainlink calls it Decentralized Oracle Network, the DON, which does all the operations associated with their services. And how that typically works is that the Oracle network has different nodes that can be run by anyone. You can set up a node. You don't even need to stake link for it. So you can become a Chainlink node operator. They perform all these off-chain operations because that's the purpose of an oracle. It's the purpose to bridge from on-chain to off-chain world, the sharing of data between blockchain, on-chain, and whatever you need from off-chain. So how this typically works is that on each chain, Chainlink has integrated, you have a so-called Oracle contract. That contract communicates with an Oracle node or several Oracle nodes that perform these off-chain operations. And if you, develop an application that requires some off-chain data, you would deploy a so-called Chainlink client. Sometimes they call it consumer, but it's essentially a contract that is funding most of the times and communicating with the Oracle contract that then can basically submit a request to the Oracle node and waits for the fulfillment of that Oracle request. And these requests can really have different forms, shapes and forms. And I'm going to go into that in a second when we go over the different services that Chainlink offers. So yeah, let's go back to these services because that will give you a much better idea what Chainlink is used for. And I wanted to start with the data feeds because that's probably the one that you're most familiar with and the easiest to understand. So when we go to data feeds, you will see here in the documentation there are actually different data feeds that Chainlink provides. And one of the most popular one is price feeds. So why would you need a price feed? So price feeds are very important in the blockchain world because first of all, a lot of liquidity is fragmented across within the same chain. It's also fragmented across chains and off chain as well. So you have decentralized exchanges on different chains that trade the same token or coin. And then you also have centralized exchanges, and each of these basically liquidity providers, they have different prices. And yes, you have arbitrage going on to more or less equalize these prices, but there are lots of applications that just want or need an average and stable and reliable price estimate of an asset, and that's where Chainlink comes in. So the Chainlink nodes actually acquire from different data sources the price data of an asset and then come to an agreement what the price is, which is then made available to smart contracts on chain. This is very important, for example, in like when it comes to lending, you need reliable data, price data to perform liquidations. And we're going to talk about that in a second as well, because there is actually something quite interesting going on with that. But yeah, you basically, when you do not use an oracle, there are actually quite some exploits that can happen because liquidity pools can be manipulated and being exploited that way unless you have a reliable oracle that provides the price. They also have something like smart data feeds. I'm honestly not very familiar with that type of feed, but for example, they have different protocols can provide proof of reserve feeds to monitor their reserves essentially. And then other things I'm not very familiar with, and therefore I'm not going to really go into it. It's more related to stocks and asset management. Then there is an interesting feed that's called SVR feeds. I actually wasn't very familiar with this before, but when you read on it, it's actually quite interesting. So you might be familiar with maximal extractable value. You probably have heard of it. If you have traded on decentralized exchanges, you might be very familiar with math bots that basically can sandwich you. So they put in a transaction before you trade, they get it at a cheaper price, and then they're going to sell on you because you basically increase the price through your trade, or it can also go the other way around. But yeah, this maximal extractable value is essentially when searchers and block builders and validators can extract value from data they have available that others don't. So they might see a transaction that is to their benefit and they can reorder them. They can put in additional transactions if they want to, and that way they can extract some value. So you have this same thing when you work with oracles, because if you're the first person that sees an oracle update, you can take advantage of that update. So what that's called is an oracle extractable value. So it's not MEV, but OEV. And basically, it's the same thing. It's a subset of MEV that is just related to oracle updates. And for example, a very relatable example is liquidation transactions. So basically, someone can take advantage of liquidations when they see that the oracle, when they are the fastest in reading the oracle update and perform the action. And so this is basically fair game for everyone if the oracle just updates publicly. Everybody has the same access to the data, and so you just basically have a competition who can extract this value first. It might not always be beneficial to the protocol. It might hurt users in certain ways. Value recapture, SVR. And this is essentially a way of having a private, like they call it a dual aggregator. So they have public Oracle updates, but also private ones. And the protocol can basically sort of subscribe to this private update. It can capture some of that value that is extracted back to the protocol, and obviously Chainlink takes a cut as well. So here you see this a little bit better. So you have the Dawn, which is just the centralized Oracle network, which provides the price updates. You have a standard feed that everybody can read. It's like the public price feed, for example. And then you have an order flow auction where searchers can put in a liquidation bid based on the private Oracle update. And this is based on this SVR feed, which is private and where the Oracle updates are posted first. So that way the protocol can basically capture some of this value that would otherwise just go only to the searchers. So it's a way of having for protocols to generate revenue themselves as well, and obviously for Chainlink as well. So yeah, there are other price feeds that are available. So you have rate and volatility feeds. These are just additional price data kind of metrics that you can consume with a smart contract. You have L2 sequencer uptime feeds that can be very useful for applications that are on layer 2s. So they are aware when a sequencer is down, and they might delay or halt some of the executions in their application to not like basically have a breakdown of the application when the sequencer is down. So these are the different price feeds. And Chainlink has recently also integrated Solana, Starknet, and Aptos, I see. That used to be just EVM, but now it actually has included quite a few networks for consumption of these data feeds. So when we go back, we see that there are also data streams. They're actually very similar to data feeds. The only difference is that it's a pull-based system and not a push-based. So when we here go to concepts and look at the architecture, we see a comparison somewhere. Let's see if I can find it. I thought they had a nice graphic here, but I'm missing it here. Maybe it's under overview. Price feeds is actually push-based oracles. So that means that the Oracle network updates in a certain frequency, and contracts can basically just retrieve that data. That's, for example, when you don't need like necessarily real-time data of a price, so it's sufficient if it's updated periodically. But also the data is always updated even when nobody needs it. Now, these data streams are pull-based oracles, which basically means that a DApp interacts with the Oracle network and gets very low latency price updates on an on-demand basis. Obviously, it can also be automated, but this provides just a different way of fetching the data that is more up to date than it might be in a push-based Oracle. And there's additional ways to verify that this data is accurate and so on. I haven't used data streams so far, but trading application might use that because they might need a little bit more frequent updates than the push-based historicals offers. So what else? So the next service we can look at is, since we've talked briefly about automation here, automation is an because blockchains on smart contracts can't execute themselves. They always need another contract or another account to trigger it. And so if you have an application such as a lottery, for example, where you have a certain time interval and to draw a winner, you need something that triggers the contract to draw the winner. Now, Chainlink provides this automation component that is very important. So that is this so-called upkeep contract on chain, and which then can, which is performing this trigger to the smart contract in the interval that is specified by the user. So this trigger can be, you see here, triggers can be time-based. It can also be event-based, because also blockchains, they can't read their own events. Smart contracts do not have access to that information. They only can read the storage. And or it can be a custom on-chain logic that needs to trigger something. So the Chainlink, the Chainlink DON essentially is always checking with the upkeep, is triggering the upkeep contract, and that one, the upkeep contract is checking if a trigger should be performed or not. And so you can do any type of automation that way. And for example, what I discovered is that, for example, on Solana, I was working on a program that really needed this automated component. And I could not find a decentralized service that would provide that on Solana that was still maintained. There were some projects implementing that stuff, but it was discontinued, and obviously you don't really have nodes to do any work. So it would just basically, there is nothing really at the moment that can provide this type of automation on Solana, which surprised me, to be honest, given the traffic on the Solana chain. So yeah, another very key component to making Web3 interesting. So another key aspect that blockchains can't do, but Chainlink solves, is verifiable random functions. And this is needed because blockchains are deterministic, so there's no real good way to generate random numbers. And you go back to the lottery game, you need a random number to draw. There are lots of different applications where you might need random numbers. Certainly games use random numbers a lot. Anything that uses some probability execution needs random numbers. But you can't really do that on the blockchain because it's deterministic. And there are ways to sort of like do a pseudo-random numbers, but they are just subject to manipulation by the validators because it's all public, the data, so they can possibly manipulate it and take advantage. So it's always good to use an off-chain service for random numbers, and Chainlink provides this verifiable random function VRF service that also publishes a proof that can be verified on chain that that is a really random number that is tamper proof. So a very important aspect too that Chainlink solves here. So now we come to the two services that I actually most excited about, functions and CCIP. So I actually just implemented something using Chainlink functions recently. And Chainlink functions are very exciting because they allow smart contracts to access pretty much any data from off-chain. So here again, you kind of see how this is put in place. So basically, when you create an application that needs to fetch, for example, weather data, or it needs a game result, the NFL or whatever, then you implement a contract that is inheriting this consumer contract. That is the contract that communicates with a deployed functions router that's deployed by Chainlink. That function router then communicates on a high level with the Dawn network, the decentralized Oracle network, and the Dawn then is executing an API request to any service you specify. It also can do some off-chain operations you might need, and then is basically fulfilling this request back to the functions router that then posts this data to the consumer for your application. And what did I use it for? So I wanted to implement a rarity-based reward system for NFT holders. So based on the rarity of their NFT that they were holding, they could claim different amounts of rewards. And as you may know, NFTs do not store metadata on chain, so most of them don't. So you typically store the metadata like either on a centralized server or you store it on IPFS, but either way, you're not able to access that from a smart contract. And that's where these Chainlink functions come in. So what I implemented was basically that the consumer contract would submit a request to fetch the metadata from IPFS through one of the gateways that are available, extracts the trait or the rarity of the NFT off-chain, and then submits that trait or rarity back to my contract, and I could then calculate the reward the owner of the NFT would receive. So I think it's a very cool concept, also very important because I think blockchain or decentralized services are useless if we can't connect it to what people do on a regular basis. So I feel like this is one of the key things that are essential to bring decentralized services to people. That you can use data from off-chain and do something with it on-chain. So I think there is so much creativity you can have with smart contracts now, having the ability with Chainlink functions to just get any data. So I recommend to check it out if you're a developer. It's still in beta, but I assume in the next few months they will basically release it officially because it's been in beta for a little bit, I think. So, and the last service I want to talk about is CCIP. Also a very cool service. It's currently only EVM. And here we also have some nice graphic here, I think. Yes. So CCIP means cross-chain interoperability protocol, and it is essentially a way to connect all the different chains together and send messages back and forth between them. Currently, it's, as I mentioned, just EVM, but I don't know what the timeline is to possibly integrate also other chains. But this is actually a very easy way for a developer to develop bridges, and because it allows to send messages from one chain to another, including tokens. So as you can see, if an end user, they have an account or a smart contract wallet or a smart contract that sends data, so the message and tokens possibly, you don't have to both, but either or, to the router that then communicates with the Chainlink network here. And either you can lock your tokens or you can burn them. And then it sends the message through this risk management network to provide additional security. And on the other side, on the destination chain, then you will have either you can mint tokens accordingly or unlock them. And the message is sent with those tokens to the receiver. I used this a little bit ago to develop a cross-chain NFT collection, which was minted. So basically, the user, they were using their BNB tokens to then mint on the other side on Base an NFT. And it takes a little bit to configure it, but actually overall it's actually not that of a big deal. But for the user experience, it's huge, because for the user, they just connect to the BNB network with their wallet. They do just a general transaction using their BNB tokens, and a few minutes later, in the same wallet appears an NFT on Base chain. So I thought it was super cool to see that in action. Very, very cool technology, and obviously it opens up a lot. And yeah, the future is likely cross-chain. I doubt that in a few years, people will really be aware of which chain they're using, especially the EVMs and those that work together. So yeah, a very cool feature. CCIP is also used, I think, with other services, which I'm not super knowledgeable of. But for example, banking systems can hook into CCIP and allow the users or customers to transact chain agnostically their assets. So this is, I think, a super cool technology. So yeah, these are the 6 services that Chainlink provides, and I hope that gave you a little bit more understanding of what Chainlink is doing. And as I mentioned in the beginning, I really love Chainlink because there are these key problems. There are true problems when you are, especially when you're a developer, that you are facing, and they're providing very high quality solutions with very with strong emphasis on security and strong emphasis on keeping it decentralized, like kind of the original vision of crypto, which I think is often lost in in many projects where people don't care anymore whether it's decentralized or centralized. But this is real. It's such a great project, and when you're a developer and you haven't checked out Chainlink, I highly recommend it because they have amazing tutorials and guides to get you started on it. And yeah, I'm a huge fan. So yeah, I hope that gave you a little bit more understanding what's possible, what the problems are across the blockchain space. So I'm going to do educational videos like this, hopefully like once or twice a week from now on, and I'm going to hold those in spaces on X. So go to the description of the video and give me a follow on there. And yeah, if you like this video, give me a like, and I hope to see you next time again. Thank you. Thanks for watching.